friends, how are you? I hope you all are well. A new day, a new beginning. Today in this video, I am going to explain one new topic, what I have written, electric charges and field. It is a topic of plus 2 second year, or you can say intermediate second year. It is one of the important topic. In this topic, we will study about electric force. We will study about the charges. We will study about the field. Particularly, we will study about the electric charges at rest. That means I can say that I shall explain about the electrostatics. Mainly, this is electrostatics. Electrostatics in the sense the study of charged particles, or I can say that the study of electric charges at rest. So, in your high school level, you might have studied electric current or current electricity. That is the study of charged particles in motion. In this topic, we will not discuss anything about the charged particles in motion. We will learn about the charged particles at rest. That's why the heading I have written here, electrostatics. That means we study about the charged particles or electric charges at rest. So, whenever we will study about the charged particles at the rest, so definite we have to go to the concept of electric charges. So, let us start from electric charges. What is electric charge? In fact, it has no definition, but we have to know what is electric charge. So, electric charge. Here, every matter consists of large number of elementary particles, or we can say fundamental particles. With the advancement of science and technology, we have discovered numbers of elementary particles, but out of all these elementary particles, some particles are there rare. Some particles in the present time no importance. So we give importance at present time. Three important elementary particles or fundamental particles. They are the electron, proton and neutron. Okay, so mass of electron, we know that 9.1 into 10 to the power minus 31 kg, whereas the mass of proton is equal to 1.67262 into 10 to the power minus 27 kg, whereas the mass of neutron is equal to 1.67493 into 10 to the power minus 27 kg. About the charge we will discuss here. See here. So, these three are the most common we are using in present day physics. I said that hundreds of particles are there, some particles are rare, some particles are no use at present. Okay, so these three we consider the fundamental particles of atoms. Now you see that we are discussing about the electric charge. I said that charge has no definition, but I shall try my best to explain what do you mean by charge, or we can frame a sentence like definition, no doubt. See, here if two electrons are there, suppose these two electrons are at a distance of 1 centimeter. I have mentioned they have the mass. Some reason is there. If the distance between them is 1 centimeter, definitely there is a force of attraction. We know that any massive body has a gravitational force. If a body having mass, so definitely there will be a gravitational field, there will be a gravitational force. So according to the law of gravitation, if I calculate the force of attraction, gravitational force always attractive force between the two electrons, that means if I use the formula F is equal to G m1 m2 by r square, that means G equal to gravitational constant 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, and if these two are the electrons, that means I can write 9.1 into 10 to the power minus 31 kg. Okay, m1 into m2, so I can mention like this, divided by r square. If the distance is 1 centimeter, that means 10 to the power minus 2 meter square. This is the gravitational force between two electrons when the distance between them is 1 centimeter. If I calculate, I shall find 5.5 into 10 to the power minus 67 Newton. Listen carefully. This is the attractive force between two electrons when they are 1 centimeter apart. This is a gravitational force. Okay, but at the same time, if two electrons are 1 centimeter apart, there is another force is there. That force is equal to 5.5 into 10 to the power minus 67. Sorry. So that force will be equal to 2.3 into 10 to the power minus 24. 10 to the power minus 24 Newton. This is the electron, this is the electron. 1 centimeter apart. There is a repulsive force. This is the repulsive force. Before that, I said attractive force. That is the gravitational force. But if two electrons are very close, definite there will be a repulsion between these two forces. That repulsive force, if the distance is 1 centimeter, is 2.3 into 10 to the power minus 24 Newton. And this force is far more than the gravitational force. This force is nothing but the electric force. So, I want to say that in addition with the mass, electron having mass, definite some other properties are there. Which properties responsible for this electric force? If there is a mass, definite there is a gravitational force. I said there is a gravitational force between the two electrons because according to law of gravitation, everybody in the universe attracts every other body. It may be electron, does not matter. I said that the distance between the electron is 1 centimeter. I am not telling the distance is infinity. If the infinity, the gravitational force is 0, no doubt. But now the electrons we are discussing very close. There is a gravitational force. At the same time, there is a repulsive force between the electrons. So that repulsive force I have written, it is 2.3 into 10 to the power minus 24 Newton. So I can say that in addition with the mass, they have another property which is responsible for this electric force. That property is nothing but the charge. So I can say that charge is an intrinsic property, or you can say that it is the fundamental property or basic property. So I can define like this way. Charge is the basic property of matter. Property of matter. Matter in the sense you can say the fundamental particles or elementary particles. Okay? Fundamental particles, or you can say elementary particles. So charge is the basic property of matter, or I can say that it is the basic property of fundamental particles or the elementary particles. Those particles are present inside the atom which can cause it to experience a force when it is placed in an electromagnetic field, both electric and magnetic field. So I have written that it is the fundamental property of matter, the basic property of matter, which can cause it to experience a force when it is placed in the electromagnetic field. So how I said that if the two electrons are there, they repel each other with a force. I said if the distance is 1 centimeter, the force is 2.3 into 10 to the power minus 24 Newton. What about the proton? Similarly, here is a proton, here is a proton. The distance between 1 centimeter, they will also attract with a gravitational force. They will also repel. They will also attract with the same gravitational force like the electrons. They will also repel with each other with a force which is equal to 2.3 into 10 to the minus 24 Newton. That means proton also having electric force. There is a gravitational force, at the same time there is an electric force. As a result, they repel each other. What about the neutron? What about the neutron? Suppose this is a neutron, this is another neutron. There is a distance between them is 1 centimeter. So between these two neutrons, only there will be a gravitational force, which can be calculated by using this formula. Okay, only there will be a gravitational force between the two neutrons. There will be no repulsion. There will be no repulsion. The fact is that neutron having no charge. Neutron having no charges. Two electrons, they are repelling. Two protons, they are repelling because there is a electric force. But in case of the neutrons, there is no electric force. There is no repulsive force. Only the attractive force, that force is due to gravitational force. Since it has mass, so definitely there will be a gravitational force. So one thing we confirm that electrons having charge, protons having charge, whereas neutrons having no charge. That means we say it is neutrons. Then how many types of charges are there? So types of charge. So I can say that there are two types of charges are there. Why we are thinking about the two types of charges are there? See that. Suppose this is a electron, this is a proton. The distance between them 1 centimeter. In this case, there will be an attraction between electron and proton. That attractive force also 2.3 into 10 to the power minus 24 Newton. Previous case we discussed two electrons repulsive force, two protons repulsive force. But whenever we are taking electron and proton, that force is electric force, but it is attractive force. The amount is same 2.3 into 10 to the minus 24 Newton. Now, if I take, suppose a very small packet. In that packet, I have taken one electron and one proton. The net charge, what will happen? It will neither attract nor repel to electrons or protons. That means, if in a small packet, small volume, if I take one electron and one proton, its net charge becomes 0. Here the net charge becomes 0. What does it mean? So it helps us to say conveniently these electrons and protons are of opposite charge. Electron and proton are in opposite charge, or electrons and protons are opposite charge, because we found that both electron and proton, when you are combining, their net charge becoming 0. So I can say that strength of charge on electron is also equal to strength of charge on proton. So strength of on electron is equal to strength of charge on proton, but opposite nature. The nature is opposite. Electron they are repelling, proton they are repelling, but electron proton there is attractive force. So their nature is opposite. So strength is equal, but nature is opposite. So conventionally, arbitrarily, we have accepted electron negative charge, proton positive charge. Both charges are equal. 1.602 into 10 to the power minus 19 coulomb, no doubt at all. But one is positive, one is negative. Positive and negative means electron has taken some loan, you are thinking it became loony. Not like that. We have only accepted electron as a negative charge, proton as positive charge. Actually, there is nothing is there difference. Both having the equal charge. For our understanding, we have accepted one is negative charge, that is electron, one is positive charge, because we found that when I take in one electron, one proton in a small volume, the net charge is 0. That's why these two charges are opposite. We conventionally accepted electron is a negative charge, whereas the proton is positive charge. So what is the unity of a charge? So we studied two types of charges, positive charge, negative charge. In this topic, we will discuss about the charges at rest. So before that, we should know details what is charge. Our concept should be very clear. The exam may be NEET, it may be JEE or JEE Advanced, does not matter. Everywhere the charge of electron will be same. Some people say this is JEE exam, this is NET exam, any exam, it does not matter. Some more exams will be added. Our concept should be very clear. So children, don't forget to share this video to your friends, at the same time don't forget to comment on it. Let us come to the topic. So we found that there are two types of charges. One is the positive charge, one is the negative charge. Then what is the unity of the charge? So the SI unit is coulomb. The SI unit of charge is coulomb. Right in the symbolic form C. Then what is the coulomb? 1 coulomb is the amount of charge flowing in 1 second. So I can say that 1 coulomb is the amount of charge flowing through a wire in 1 second when the current is 1 ampere in it. In current electricity, you have studied I is equal to Q by T, or you have studied that Q is equal to I into T. This current is 1 ampere, time is 1 second, then the charge is 1 coulomb. Same thing I have written here. Okay, so this is about the unit of charge. One more fact. Charge is quantized. Charge is quantized. That means up to now we discussed in this universe two types of charges. One is positive charges, one is the negative charges. All those particles are there, they have charges, no doubt. But all time a body bears an integral multiple of charge. Integral multiple of, you can say, charge. What? Charge of electron is found 1.602 into 10 to the power minus 19 coulomb. One particle is there this much. Two particles means I shall multiply 2. Three particles means I shall multiply 3. So all the time it will be an integral multiple. One integer will be there, not fraction. I can't say that the charge is 1 by 2 of this one, 1 by 3 of this one, 1 by 4 of, not like that. All the time the charge is an integral multiple. Now I can say that charge is conserved. See one more point. So charge can be quantized. It can be expressed in certain quantity. What is the integral multiple of its charge? Okay. So now I am telling that charge is conserved. What is that charge is conserved? Charge is conserved. In an isolated system, the total charge is fixed. Charge can be created, charge can be destroyed. A new charge can be created, can be destroyed. But a new charge can be created or destroyed, no doubt. But the total charge of the system remains constant. There will be no change in total charge. We have studied in beta decay. One proton convert into neutron and electron. No doubt. But the total charge of the system remains constant. We can create, no doubt. But the total charge of this system is conserved. So I written that charge is conserved. So dear students, today in this video I explained in detail about the charge. So in the next video I shall explain about the electrification and about the coulombs and many more things. So this video just for the introduction of the topic. So in coming days some more beautiful videos will get. I hope that for your consistent study, don't forget to subscribe. Thanks.